Okay, so this is your first video lesson for ACP Geometry, Section 1.1, Patterns and Inductive Reasonings. Okay, so this is the Chapter 1. We are going to cover all sections. Okay, and this packet has Section 1. After Section 3, we're going to have a quiz. And after Section 7, we're going to have a test. Okay? So this packet has one objective, and by the end of this lesson I will be able to use inductive reasoning to make conjectures. Okay, so I want you to write that on your packet. Okay, and here's the vocabulary. Inductive reasoning: making a conclusion based on a pattern of events. Okay, and conjecture, so is a conclusion reached using inductive reasoning. Okay, and counterexample, a particular example or instances of the statement that makes the statement false. Okay, so the objective here is to make inductive reasoning. And what inductive reasoning is to make a conclusion based on what you see, like in the patterns. Okay, and this conclusion that you make is called conjecture. Okay, so the conjecture is the result of inductive reasoning, and conjecture is different from theorem. The conjecture is, because I observe these things, I think this is true. For example, because I observed that every triangle I measured have an internal sum of 180 degrees, I conjecture that every triangle has internal angle sum of 180. That is a conjecture until you prove it. Once you prove it, that is always true no matter what triangle you draw, then that becomes a theorem. Okay? And the counterexample is just one example that that conjecture is not true. Then it becomes false. The conjecture becomes false. Okay? And the process of that making, I think because I observe these things, this is true, is called inductive reasoning. Okay? So that's what we practice in this packet. So here's example. Okay? X equal x times x. So this is basically saying x equal x squared. Now, you know this is true when x equals 0 or x equals 1, right? Because 0 equals 0 squared and 1 equals 1 squared, right? But you also know that that is not true for any other number but 0 or 1. For example, 2 is not 2 squared. 3 is not 3 squared, right? So, by observing these two patterns, you may have concluded this is true, but by giving one counterexample, you prove that that this is false. Okay, so that is for example, x equals 5 is counterexample to prove that this conjecture that this is true is false. Okay, here's another example. Make a conjecture about the sum of the first 8 odd numbers. Find the first few sums and notice that each sum is a perfect square. So 1 equals 1 is square of 1. 1 plus 3 is 4, is square of 2. 1 plus 3 plus 5 equals 9, which is square of 3. 1 plus 3 plus 5 plus 7 is 16, which is square of 4. So, observing these patterns, you can make a conjecture. Make a conjecture about the sum of the first 8 odd numbers. Use your calculator to verify your answer. So, try that right now. Here is my calculator. Okay, and we are going to add the first 8 odd numbers. So let's see. So that would be 1 plus, can you see that? Just make it closer. All right. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. How many times is that? 1, 2, 3, 4, 5, 6, 7. So one more, 15. That is 64, which is 8 squared. So we make a conjecture that odd of integers, I mean, the sum of the odd integers is a perfect square, and it looks like it's true, and there is actually a proof for that, which I can show you in the class. Okay, so in this case, the conjecture was true, and then it has been proven. So once it's proven, that's a theorem. All right, so here are some practices to do. So these problems, you're just looking for patterns. Okay, so I want you to do odds for homework here. All right, we're going to do a few evens as an example. Okay, so for example, this one, so the next 2 terms, that's what you have to do. Okay, so this one, each time the 3 is going up, so this would be 33,333 and so forth. This one is going half and half and half, so it's going to be 116, 132nd and so forth. Okay, and then this one you're dividing by 3, right? So it's going to be 1, 1/3 and so forth. This is an interesting one. I'm going to try that one. And this one is alphabet. Do you see the pattern? So January, February, March, April, May, June, July. Okay, this one is just squaring. Okay, all right, let's see here. Martha, Abigail, Martha, Dory. Martha, Abigail, Martha, Dory. So does that mean that it's just Martha? So next should be Martha. And any other girl's name, I guess. If you see any other pattern, let me know. Aquarius, Pisces, Aries, Taurus, Gemini, which is me. Next to Gemini is that. After Gemini is what? Cancer. All right, and so forth. Try these two. Okay. All right, and then see a few more, and we'll be done for this video. Use the table and inductive reasoning. Make a conjecture about each values. Oh, look at that. So these are adding odd numbers. Okay, and then odd numbers are actually 1 times 2, 2 times 3, 3 times 4. It's an interesting number thing here. All right. The sum of the first 6 positive even numbers, the sum of the first 30 positive even numbers, the sum of the first 100 positive numbers. Use the pattern in example 2 to make a conjecture about the sum of the first 100 odd numbers. Right, I think I want you to try this as a homework. I think you can do this. Okay, and we do the rest in the class. Okay.